Hello friends, this video on triangles part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. Now let's start with angle bisector concept. What is angle bisector? So we have this triangle. Let's have this be a triangle. Let this be point A, this be point B, and this be point C. So we have this triangle. So there are two kinds of angle bisector. One is called internal, I'll write here, internal angle bisector, and the second is called external angle bisector. We'll study both actually. So in first case, we'll go for internal angle bisector. So this is the triangle, and let's suppose this is the angle A. For angle A, if I want to find internal angle bisector, I'll draw like this. This is angle A. I drew an internal angle bisector, right? So in this case, this angle will be 1 and this angle will be 2, where angle 1 will be equal to angle 2. Both angles will be equal. So you have an internal angle and you bisect this. Though this line, let's suppose this is D, AD is called internal angle bisector. Now let's draw external angle bisector. We draw this triangle. We have this point A, B and C. This is a triangle now. Now for this same angle A, I want to draw external angle bisector. So external angle is this angle. So first extend this. We have extended this. So this is our external angle. Correct? This is the internal angle. This is the external angle. Now we will draw external angle bisector for this A. What we'll do? We'll draw this point also. Extend this. Why? Because it will meet somewhere here. Right? Now we'll draw this angle bisector. Correct? So if you see this angle, let's suppose is equal to 3 and this is 4. So here angle 3 is equal to angle. It meets at 1. So this is example of external angle bisector. So what we have done, we have drawn this same triangle ABC. In first case, we drew internal angle bisector. So we got this internal angle. We drew a line AD such that angle 1 is equal to angle 2. In second case, we were supposed to draw external angle bisector. So point A, we extended this, we got this external angle. This point also we extended because we wanted this point to meet somewhere. And then we drew this angle. So we drew this line AD such that angle 3 is equal to angle 4. So here AD is external angle bisector and here AD is internal angle bisector. That is the concept of internal and external angle bisector. Let's have an activity for internal angle bisector. Let's draw this angle. Once we have this angle, right, let's draw this point. All these points, equidistant point, and here also let's draw this point. Now let's join this point, this point. If you see this, just like that we have joined these points here. If you see this is 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This 11 units here. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units here. Correct? So we have got a triangle of side 11 and 9 and this is triangle. Now we draw an angle bisector such that this angle 1 is equal to angle 2. Correct? This was 60 degree, we drew 30-30 each. So we do this angle where angle 1 is equal to angle 2. Now let's put the points. This is D, this is A, this is B, and this is C. So now that is nothing but one triangle ABC, and AD is the internal angle bisector. Now if you measure this point, this is let's suppose X and this is let's suppose Y. If you measure this, if you take the measurement of this BD and DC, you will see that, will observe that AC by AB is always equal to CD by BD. That is 11 by 9 will always be equal to X by Y in this case. If you take this point, then AC will vary, it will be different value. That's how it is. You take any angle, create angle bisector, and then you'll observe that this AC by BD will always be equal to CD by BD. This you can try in your paper with a pen or pencil. This will always be true. This is an activity. Now we'll have a theorem to prove it also. Theorem for internal angle bisector. The theorem says internal angle bisector of a triangle divides the opposite sides internally in the ratio of the sides containing the angle. We have seen this, that if this is the triangle, let me draw a bigger triangle. This is the triangle ABC, right? And this is the angle bisector. AD is the angle bisector. Then AB by AC is equal to BD by C. Correct? We have to prove this. To prove this, let's draw a triangle. This is triangle, and this is ABC is a triangle, and this is the angle bisector actually. So let's suppose this is point E. A is the angle bisector. To prove this, let's draw a line C parallel to A, and also let's extend this line to meet at this point, and let's call this point as D. Why we have done this? Because till now we know only Thales theorem. So if we have this line and this line parallel, we can use Thales theorem property. That's why we have extended this CD parallel to A, and this angle is 1 and this angle 2, where angle 1 is equal to angle 2 and AE is parallel to CD. These are the two things we have. So what we have to prove? We have to prove that AB by AC is equal to BE by EC in this diagram. So let me cancel this, right? In this diagram, AB by AC is equal to BE by AC. So what is the approach we should follow? If you see, since these two are parallel, BE by EC, that is on the right hand side, this one will be equal to AB by AD. Correct? You can write CD. BE by, just going by the reverse approach, BE by EC. This is equal to, if you see, BE by AC is equal to AB by AD. Correct? By Thales theorem. By Thales theorem. Why? Because A is parallel to CD. Now we are supposed to prove that BE by AC is equal to AB by AC. So instead of AD, we have to prove AC. So if somehow we can prove that AD is equal to AC, our issue is solved. Correct? We can prove that AD is equal to AC, our issue is solved. So let's see, can we prove AD is equal to AC? Let's try this. This angle 2 is equal to angle 2 dash. Why? Because A is parallel to this. So alternate angle. So this angle is equal to this angle. Similarly, angle 1 is equal to 1 dash. I'll put this as 1 dash. Why? Because this and this are same. So what we have seen? Angle 1 is equal to angle 1 dash. Why? Corresponding angle. And angle 2 is equal to angle 2 dash, alternate angle. Now, since angle 1 is equal to angle 2, it's already given, right? It's given here. So we can say that angle 1 dash is equal to angle 2 dash. If angle 1 dash is equal to angle 2 dash, then ACD is a isosceles triangle. So we can say that AC is equal to AD. Correct? If AC is equal to AD, instead of AD I can write AC here. So this equation, I'll put this equation here. This equation will become B by EC will become AB by, instead of AD I'll write AC. And that is what I wanted to prove. Hence prove. So thus by using Thales theorem I have proved the angle bisector theorem. That is, if A is the angle bisector, then AB by AC is equal to BE by EC. Correct? Please understand what I have done here. I have just drawn a parallel line because I knew only Thales theorem till now. And in Thales theorem, if you have parallel line, you can find the ratio. BE by EC by Thales theorem becomes AB by AD. But I wanted to prove BE by BC is equal to AB by AC. That means AD should be equal to AC. Then somehow I proved that AB is equal to AC. How? I have proved that angle 1 dash is equal to angle 2 dash. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.